Sine waves are generally used to represent the fluctuating values of AC voltage and current over time. The height of this function is equivalent to the vertical projection of a rotating vector, which traces the circumference of a circle with radius r through an angle theta. In electrical engineering, these purely AC voltages and currents are represented using Am sine 2 pi ft plus theta or Am sine omega t plus theta. Here, Am is the sine wave's peak value. To simplify the process of AC circuit analysis, we represent that rotating vector at time equals 0 in polar or rectangular form. These forms do not carry information about the wave's frequency, but allow us to apply circuit analysis laws, like Ohm's law, KVL, and KCL, that were used in DC circuits in AC circuits as well. Both polar and rectangular vectors exist on the complex plane, with a real x-axis and an imaginary y-axis. From the rectangular form, we can see that the vector z bar is just the sum of a real and imaginary vector. The j operator in the imaginary vector just rotates it 90 degrees anti-clockwise about the origin, so it points up. By convention, polar and rectangular forms don't use peak but instead RMS values. Hence, to represent the Cartesian sine wave in polar or phasor form, we need to convert the peak value or amplitude of the wave to RMS by dividing by root 2. The result of this is our radius r of the vector, and theta is just the same value as in the Cartesian form. In our example, where V peak equals 5 root 2 volts sine 2 pi 100t plus 60 degrees, the radius becomes 5 volts, and theta is just 60 degrees. So Z bar becomes 5 volts angle 60 degrees in polar form. From polar form is the easiest way to convert to rectangular form, using the equations x equals r cos theta and y equals r sine theta. Following on with our example, x would equal 2.5 volts and y would equal 2.5 root 3 volts. Hence, Z bar would equal 2.5 volts plus J 2.5 root 3 volts. Remember, we're still using RMS values. This can also be done using your calculator's rect function. We can convert back to the polar form from rectangular form using the equations r equals square root x squared plus y squared and theta equals inverse tan y on x, or the pole function on our calculators. Looking at our example, we say r and theta equal 5 volts and 60 degrees respectively, again giving us Z bar equals 5 volts angle 60 degrees. Given we know the frequency, we can easily convert back to the Cartesian form from polar form. We do this by plugging in the f and theta values and by converting r back to a peak value from RMS by multiplying by root 2 before plugging in that as well. Thanks for watching.